Good morning, students. In this session we are going to see a subject hybrid and electric vehicle technology. From the subject today we are going to see a topic on configuration and control of DC motor drives. DC motor. The DC motor drive is a type of amplifier or power modulator that integrate between the controller of and the DC motor. It takes a low current and then converts it into a high current, which is approximate for the motor. The DC motor drive also provides the high current torque, that is a 400% more than the rated continuous torque. The important application of DC motor drives are rolling mills, paper mills, mine windows, hoist and machine tools, traction, printing presses, text mills, and excavators and cranes. Types of DC motor drives. First one is a non-regenerative DC motor. The drive rotates only in one direction and hence also called single quadrant drive. The non-regenerative DC motor does not have any inherent braking capability. The motor is terminated only by removing the supply. Such type of drive is used in a place where high friction load or strong natural brake requires. Regenerative DC drive. It is a fourth quadrant drive and it controls the speed, direction and torque of the motor. Under the braking condition, this drive converts the mechanical energy into load and into electrical energy, which is returned to the power source. Braking of DC motor drives. The braking is a phenomenon of reducing the speed of DC motor drive. In braking, the DC motor drives works as a generator. It develops the negative sequence torque which opposes the motion of drive. The braking of DC motor drive is mainly classified into three types, that is regenerative braking, dynamic braking and plugging. It is a regenerative braking. In regenerative braking, the generated energy is supplied by the source. For regenerative braking, following conditions should be satisfied. It is a diagram for regenerative braking. Dynamic braking. In dynamic braking, the rotation of the arm causes braking. The motor or armature disconnects from the source and connects across a resistant. The figure of the separately excited DC series motor is shown in figure below. It is a separate excited motor and the series motor diagram for dynamic braking of DC motors. The series machine works as a self-excited generator and the field connection reverses, so the field assists the residual magnetism. The curve shown below shows the speed torque curve and the transition of motoring to braking. We can see in the diagram separately excited motor, that is a braking and motoring system, and also series motor, there is a curve for a braking and the motoring system. Plugging. In plugging, the braking is done by reversing the supply voltage of a separately excited motor so that the motor assists the back EMF in forcing an armature current in the reverse direction. Resistance is also connected in series with the armature to limit the current. The plugging gives a fast braking as compared to the generative and dynamic braking. Speed control methods of DC motors. The speed of the DC motor drives can be controlled by any one of the following methods. That is armature voltage control. This method prefers because it has high efficiency, good transient response and a good speed regulation. It provides a speed control only below the rated speed because the armature voltage cannot be allowed to exceed the rated value. There is a graph for armature voltage control. Next one is a field flux control. This method is used for controlling the speed above the rated value. Normally, the maximum speed of the motor is twice the rated speed, and in the special motor, it is 6 times the rated speed. Armature resistance control. In this method, the speed is varied by wasting power in external resistor that is connected in series with the armature. This method is mainly used in alternative load application where the duration of the low speed operation forms only a small portion of the total running time. Thank you.